What actually sensors are. In simple terms, sensors are sophisticated devices that are frequently used to detect and respond to electrical or optical signals. A sensor converts the physical parameter, for example, temperature, blood pressure, humidity, speed, etc., into a signal which can be measured electrically. Let's explain the example of temperature. The mercury in the glass thermometer expands and contracts the liquid to convert the measured temperature, which can be read by a viewer on the calibrated glass tube. Now a question here can be raised that what is the criteria to choose a sensor, or on what properties it should be selected? Precisely, there are certain features which have to be considered when we choose a sensor. They are as given below. 1. Accuracy. 2. Environmental condition. A sensor usually has limits for temperature and humidity. 3. Range. To what extent a sensor can measure. 4. Calibration. It is essential for most of the measuring devices as the readings changes with time. 5. Resolution. It means the smallest increment detected by the sensor. 6. Cost. How much money would it cost? 7. Repeatability. It includes the reading that varies as repeatedly measured under the same environment. On the other hand, sensors are also classified by the implementation of following criteria. 1. Primary input quantity measurement. It is a terminology which precisely can be described as an object being measured, or a physical quantity or property which is measured. 2. Transduction principles, using physical and chemical effects. For example, a device that converts electrical energy into mechanical energy can be referred to transduction process. 3. Material and technology. For instance, what kind of technology is used, rather modern or old means of technology, or what kind of material it is on which sensor is applied to. 4. Property. The property of matter is always considered when the sensor implementation is needed. 5. Application. Application is the most significant part in determining which type of sensor should be used, whether UV sensor or temperature sensors when measuring the temperature of atmosphere. Transduction principle is the fundamental criteria which are followed for an efficient approach. Usually, material and technology criteria are chosen by the development engineering group. When expatiating about the types of sensors, some commonly used sensors along with the principle and applications are explained as follows. 1. Temperature sensors. This device collects information about temperature from a source and converts into a form that is understandable by other device or person. The best illustration of a temperature sensor is mercury in glass thermometer. The mercury in the glass expands and contracts depending on the alterations in temperature. The outside temperature is the source element for the temperature measurement. The position of the mercury is observed by the viewer to measure the temperature. There are two basic types of temperature sensors. Contact sensors. This type of sensor requires direct physical contact with the object or media that is being sensed. They supervise the temperature of solids, liquids and gases over a wide range of temperatures. Non-contact sensors. This type of sensor does not require any physical contact with the object or media that is being sensed. They supervise non-reflective solids and liquids but are not useful for gases due to natural transparency. Working example of temperature sensors. I. Thermocouple. They are made of two wires, each of different homogeneous alloy or metal, which form a measuring junction by joining at one end. This measuring junction is open to the elements being measured. The other end of the wire is terminated to a measuring device where a reference junction is formed. The current flows through the circuit since the temperature of the two junctions are different. The resulted millivoltage is measured to determine the temperature at the junction. 2. IR sensor. This device emits and/or detects infrared radiation to sense a particular phase in the environment. Generally, thermal radiation is emitted by all the objects in the infrared spectrum. The infrared sensor detects this type of radiation which is not visible to human eye. Our sensors comes up with many pros and cons. While looking upon its benefits, it is easy for interfacing and readily available in market, and while having an overview on its cons, it is disturbed by noises in the surroundings such as radiations, ambient light, etc. How does it works? When IR receiver is subjected to infrared light, a voltage difference is produced across the leads. Less voltage which is produced can be hardly detected, and hence operational amplifiers, op-amps, are used to detect the low voltages accurately. Measuring the distance of the object from the receiver sensor, the electrical property of IR sensor components can be used to measure the distance of an object. It has many applications, e.g., heating. Infrared can be used to cook and heat food items. They can take away ice from the wings of an aircraft. They are popular in industrial fields such as print dyeing, forming plastics, and plastic welding. 3. UV sensor. These sensors measure the intensity or power of the incident ultraviolet radiation. This form of electromagnetic radiation has wavelengths longer than X-rays but is still shorter than visible radiation. UV sensors can discover the exposure of environment to ultraviolet radiation. It has many applications, e.g., measures the portion of the UV spectrum which sunburns human skin, pharmacy, automobiles, robotics, dyeing processes. Thanks for watching. Made by Abdullah Gul.